So if we just consider the graph of cube root of x, first of all, we kind of have to remember a little bit about our parent functions. You guys remember that your cube root of x graph looks something like this. And they're going to kind of lead you towards what part of that to be looking at. We're just supposed to be looking from 0 to 1. So like this little area in here is all we're really looking at. I'm going to blow that up a little bit so we can see it better. First of all, at 0, if I were to do the cube root of 0, we get 0. And if I did the cube root of 1, I get 1. And this graph curves that way. And it says the integral of that from 0 to 1 is 0.75. So as I look at the area underneath my curve, they're saying that this area right here that I just shaded in is 0.75. Okay? Not a shape we would have been able to do with like area formula we know. And we're supposed to use that to evaluate the integral given. Same interval from 0 to 1. Cube root of x, and then we have to kind of remind ourselves of all those transformation rules from pre-calc. If it says plus 1 on the outside of your function, where's that moving it? Up 1, right? Anything outside of our function moves it vertically. So if it says plus 1, it's going to move up 1. If it had said minus 1, down 1. If it had moved inside our function, that's when it moves it right or left or horizontally, right? So it's saying take this graph and move it up 1, okay? So if I do that, the point that was originally here at 0 will move up 1 to 0, 1. That point that was originally here at 1 will move up 1 to 2. And right here, we still get that same curve, right? So if I kind of ignored what was going on down here, we still have that same shape happening right here. And it's still got an area of 0.75 in there, right? But that doesn't take into account, that's only this part right here, and that doesn't get us all the way to the x-axis, so we have to also include this part right here. Well, that part is now a shape that we do know how to find, right? That's just a rectangle that has a base of 1 and a height of 1, so I would add to it, to the area of that rectangle, 1. So 1 plus the 0.75 that's on top of that would give us a total area under our curve of 1.75. Through our transformations, basically what we're going to see, especially as we move on to this next one, is I kind of look at this little box right here, which would be a 1 by 1 square. And where does that move in my picture? Because that will always kind of stay the same. And then like what rectangle or anything is being added onto that, or did it stretch or things like that. But that's kind of that's the foundation of all of these pictures. Okay, so let's try one more here. Same information at the beginning. That has not changed. The exact same thing. The interval from 0 to 1 of the cube root of x equals 0.75. So just kind of looking at a slightly different transformation this time. This time it's the cube root of x plus 1 minus 1. So first of all, again, taking a second to remind ourselves of our transformations. The plus 1 that is inside the radical, where's that moving our graph? Left. And then the minus 1 on the outside? Down. Okay, so each of those points that we had are now going to move left 1 and down 1. Okay. So we had this, again, a point that started at 0, 0. If I move that point to the left 1 and down 1, it would end up right here. I had a point that started at 1, 1. If I move that left 1 and down 1, it would end up right here. And we get that same curve happening right there. Okay? So it's kind of like that square that we had over here. If I think of that whole thing, that it got moved left 1, down 1. And that square is now happening down here. Right? So in that square, we know that this part of it, that right there, has an area of 0.75. Okay? But what has happened because of the transformation? It's now below our x-axis. Okay? Now, does that mean that it just becomes negative? yeah, we are supposed to answer how much area is between that and our x-axis, and the part I have shaded is not between my curve and the x-axis, right? So yeah, that is still 0.75. It is now below my x-axis, but the integral is asking me what is the area between my curve and the x-axis, which would be the green area. Okay, well, that's where thinking of it as a 1 by 1 square can help us, because a 1 by 1 square total would have an area of 1. I know the red is 0.75, which means the green has to be how much? 0.25. Okay, so the area between that curve and the x-axis is 0.25. What's wrong with my answer? Negative. Below my x-axis, so it is a negative 0.25. Questions on that? Okay, so remember you guys have like lefts and rights, up and downs. You also have like reflections, an ROX and an ROY. It can reflect over your x-axis with a negative outside. It can reflect over your y-axis with a negative on the inside. You've got your vertical and horizontal shrinks and stretches. So again, applying the transformation and then seeing how that impacts the original piece of information given to us. The other type of problem that you're going to see on your assignment that I wanted to make sure that we kind of talked about is basically going through what we were going through to find the area of the integral, but all variables. And a lot of times things are done in all variables, especially on like standardized math tests, but we don't like thinking in all variables. So remember that it's going to be the same. It just means that our answer probably has variables in it. So looking at this first one, the integral from a to b of 5t dt, and it also tells us that 0 is less than a is less than b, is a very similar to what you guys are going to see in your assignment in this section. I've had the 5t dt in there because for some reason your book picked a whole bunch of different variables in that section. It really doesn't make any difference. They're just saying that the independent variable t is what they're going by. That's your x. Okay, so you could write that as 5x dx as well if you wanted to. The 0 is less than a is less than b part of it tells me that if a is bigger than 0 and b is bigger than 0, they're both what kind of numbers? Positive, right? And that b is bigger than a, the way they have that written, right? That's all that's saying on there. So if I draw myself a picture of what's going on, just to kind of visualize this, our function is 5t, or 5x, if that helps you visualize it better, which means I would be graphing y equals 5t or y equals 5x. Well, that's just a line. That's y-intercept is 0, right? Y equals mx plus b. It's going to go through my origin with a slope of 5. Something like that, okay? And I'm supposed to find the area under that curve from A to B. So starting at some A value and stopping at some B value, both of which are positive and B is bigger than A. And the integral says I find the area under that curve in that area, in that region. Okay, so this part right here is what I'm finding. Okay, well, what shape are we looking at? Trapezoid. Okay, again, we can break it down by triangle and rectangle. I'll always use the trapezoid formula. So let's talk through our trapezoid formula here. Ooh, that's not what I meant to do. Give myself some room here. Area of a trapezoid is the height. What is the height of that trapezoid? B minus A, right? Remember, height of a trapezoid is the distance between its bases. So the distance between its bases, B minus A. And then we're supposed to take base 1 plus base 2. Well, how am I supposed to figure out like the length of this base? Remember? Plug it into the function, right? So if I plug b into the function, it's just 5b. This point up here is b comma 5b, which means this base is a length of 5b. Same thing on this end. That point is A, comma, plug A into our function. And when I plug A into our function, it's 5A. So the length of this base is 5A. Order there does not matter, right? Okay, now, two kind of ways that I would say. First of all, had this been like a free response question, we would stop there, right? Because we're not going to oversimplify and chance a mistake. That's not an answer we would see on a multiple choice test, though. So always good for us to see the equivalent forms of that. Let's talk about equivalent forms of that. We could FOIL, right, and kind of clean it up a little bit here. But I do want to kind of point one thing out. You see the 5B plus 5A? That little parentheses right there has a GCF, right? If I pulled that 5 GCF out to the front, 5 times a half is just 5 halves. Aren't we looking at a difference of 2 squares? So when I multiply my difference of 2 squares, we get the first thing squared minus the second thing squared. That's what you would see on a multiple choice test right there. And it might catch you because that does not initially look like that, does it? Okay, so always kind of good to see this, but that's not the last time you're going to see that happening just because they're all developed the same way. It's all trapezoids, right? Trapezoids happen all the time when we're doing these linear equations. Okay, with that same idea, I want you to try this one. You can work with your table partner if you would like. The integral from b to 3b of x dx. b is greater than 0. Okay, so again, let's break down the information that we see going on in here. It says that we're going from an interval from b to 3b. Our function is y equals x, which is just a linear equation. It does tell me that b is greater than 0, which means that even where we start is positive, right? So if I were to draw the equation y equals x, it's going to go through my origin, slope of 1, linear equation, that I'm starting at some b value, and we're stopping at 3 times that number. Okay, kind of what you guys all had going on there. So again, as I connect that to my function, we see, just like we saw in the last one, a trapezoid happening. So I can attack it just like I did the last trapezoid, 1/2 times the height. Well, the height is going to be the difference between my two bases, right? 3b minus b. And then my two bases come from plugging these into the function. So if I'm plugging in 3b into x, I just get 3b, right? So one of my bases is 3b. The other base is b. And again, that would be a just fine setup, but we really could simplify that quite a bit more. 3b minus b is 2b, or not. 2b. Okay. 3b plus b is 4b, and then we just multiply. 1/2 times 2 is 1, times 4 is 4, b times b is b squared. Questions? All right. So like I said, nothing new today, just seeing it with variables or in a slightly different format. But your assignment is some random numbers out of the book. And I did have both answer keys kind of together, so you'll have to search for those if you guys noticed checking your answers last time. Didn't even have everything, but sorry.